Alright guys, we're going to continue with our study of logarithms. Okay, we're on chapter 7.4, properties of logarithms. Okay, so the last time we looked, quizzes looked awesome. Now we're going to delve a little further into logarithms. Okay. A lot of these examples that we're going to look at require an initial formula. So when I provide it, I'll give you the name of it, I'll write the formula itself, and you just make sure you organize your thoughts there, okay? And then we'll actually apply and use the formula. Alright, let's see here. So this first problem, express log base 3 of 6, and it's good to read them, okay, as much as possible, plus log base 3 of 4.5 as a single logarithm. Simplify if possible. Alright, so this formula is called the product property of logarithms, okay, and I'll write it out here in general. So log base of any b of mn. Okay, I'm going to put an arrow, meaning I can go from here to the right side or from the right side to the left. Okay, it works in both directions. Log base b of m plus, whoops, I spelled the word bog. See here. Log base b of n. Okay. So again, this arrow or this line pointing in both directions means you can go from left to right or from right to left. In this case, they want a single logarithm, so this is the goal, for it to look like this. Okay. So down here, what I'll do is I'll put log base 3 of 6 plus log base 3 of 4.5. Okay, I'm going to be going left in this case, so I now have log base 3 of 6 times 4.5. And I'll continue working down this way, log base 3 of 27. It says simplify if possible. Okay, so let's go ahead. Notice that I've applied the formula here. I simply simplified, and then it says to go further if possible. Okay. Right. Now, one thing to keep in mind is you're always looking for bases, and can you transform them into some number, to some exponent, perfect squares, perfect cubes, or whatnot. So with some practice, you'll notice that 27 is really what? 3 cubed. Okay, why is that important? Well, there's a new formula that I can apply here. Okay, and it's a little more advanced, but this one's called the inverse property of logarithms. I'm going to go and write this one down here for you guys. This one in general says log base b. I'm going to kind of skip forward here. Okay, what do we have? Log base b of b to the x equals x. Okay, I'm going to start this. So we've used our initial formula. Okay, now as far as simplifying as far as we can go, we're going to apply this formula here. Notice what this says is if you ever have a log base b, okay, and the expression here also has a base b to some exponent, then this portion simply cancels and you're left with x. Okay. So if I go and apply that knowledge in this direction, I'll notice that log base 3 matches with this base, so that's going to cancel, and it'll produce this 3 right there. Alright, so if you can follow along, awesome. If not, just take good notes, write down the formulas. Tomorrow, do the best you can on the warm-up, and then we will definitely explore this together with questions, comments, and concerns. Okay? Alright, so moving on to this next problem. Express log base 2 of 64 minus log base 2 of 4 as a single logarithm. Simplify if possible. Notice, unlike the other one that had a plus, this is a minus. So you guessed it, you will be needing a specific formula for this kind of problem. and here it is. Okay, it's called the quotient property of logarithms. Again, I am saying it, you should be writing it. Nonetheless, here it is. Okay. Minus log base b of n. Okay. Once again, I could put an equal sign here, but I'm putting arrows to show you can go from left to right or right to left. And we've got log base b of n over n. Okay. Alright. If we look at this, we can obviously substitute down low here, so let's go and do so. We've got log base 2, 64 minus log base 2 of 4. We're going to go right on this one, and let's plug in everything appropriately, right? So it's obvious that b is 2, so that's my base, log base 2. M is 64. And n is 4. Okay. So now I can continue kind of simplifying like they're requesting. So the log base 2 remains the same. I can do the math on that and get a 16. Okay. And now I should continue further simply because I do know that 16, and this is coming from our study of exponents, is equivalent to 4 squared. Right? The cool thing about this is we get to revisit that same formula from the last example. Go down here, okay, which told you what? It's called the inverse property. And if you notice, right, when the log base matches the base of this expression here, they cancel out and you're left with this exponent. Okay. So let's go ahead and reintroduce this inverse property of logarithms and exponents. So I'm going to put the star over here on this side. So once again, I'll rewrite log base b of b to the x equals x. Right. So the application here means what? Let's see here. I'll notice that the base b here doesn't match the base there. Okay, as I've written it here. So it simply means I've got to try another option. So check this out. I'll go log base 2 of 2 to the 4th power, right? So let me double check. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this one is still equivalent to 16 and the same as this one. However, through algebraic manipulation, I now have set it in a form that matches this formula. And therefore, make some room here. I'm able to reduce this to what? 4, because log base 2 with this base cancel, and I'm left with this exponent. So this formula went ahead and was used in this situation. Alright, alright. Again, if you guys got it, great. If not, take good notes, write these examples. You should be great on the warm-up, okay? And then after that, we will move on to any questions or concerns you might have on this. Alright, the next example. Express log base 3 of 27 to the negative 3 as a product. Simplify if possible. Alright. Let's go ahead and introduce a formula specific to this kind of problem. And let's see here. So once I start these are incredibly valuable. So this is log base b of a raised to p. What does that equal? And let me go ahead and reintroduce, instead of the equal sign, the arrows. Mathematically, that's equivalent, by the way. And if you have this expression, you can actually write the p up front of the log base b still of a. So that property there. Okay, so let's go ahead and use this formula in this case. The question you should ask yourself is, this expression looks like which one, left or right? Okay, you can pause the video, but I'm sure you'd conclude it looks like the left side. So we got log base 3 of 27 to the negative 3. So from left we're going to go right, and this exponent of -3 will now be placed up here in the front. Log base 3 still of 27. Okay. Alright, now we've applied the formula. Okay, we're on our way to expressing it as a product. Now, what we're going to do here is we're going to pay attention to this request for us to simplify if possible. Okay. So once again, we've got the -3, log base 3, and this 27, we've seen it before, can be rewritten as 3 raised to the third. Okay. Here I'll write the formula one more time, which is what we were calling the inverse property of logarithms. So let's go ahead and rewrite it, right? Where you've got log base b of x. When the two bases match right there, you get x. So once again, I'm going to go -3 times. Okay, notice that I've got log base 3 of 3 to the third, so this part cancels. I'm left with that 3 equals, and then finally -3 times 3 is -9. Okay. Alright, let's go and march forward. Alright, this next problem says simplify the expression log base 4 of 64. So immediately what your brain should be thinking is, how can I, or is there a base 4 to some exponent that will give me 64? Okay, only because of that inverse property of logarithms. There is indeed, and if I continue working down this way, I'll realize once again that these bases cancel, right? So this is coming, and again, anytime you have formulas, write them, and write them again. Why? They just stick in your head. The formula said what? Log base b of b to the x equals x. So that's appropriate here, and I get a response of 3. Okay. All right. What else we got here? All right. This next problem says evaluate log base 9 of 243. If necessary, round your answer to the nearest 10. All right. So in this case, round your answer to the nearest 10. Alright, what can we do here? Okay. Now this one's a little more intense, so guess what? We're going to introduce a new formula, and this one's called the change of base formula, and it looks something like this. Log base b of x equals log base a of x. And I'll tell you what, I'm going to write it this way, so follow along, okay? Log of, b, okay? Now, again, it's called the change of base formula because what's ultimately going to happen here is if for some reason you do not want to work with this given base, there's a way to adjust it, and it's in the following format. Now, what I have here is technically correct, but what I want you guys to focus on, notice that this x goes here, the b goes there. I think it's very easy to write this. I'm going to introduce an a here. Okay, a is going to represent the new base, and guess what? It can be any base essentially that you would want, so long as a is not equal to 1 and a is bigger than 0. So really, it could be any base that you want, okay, in general. Okay, just with those guidelines. So with that in mind, let's go ahead and see what we can do with this problem here. Okay, so we have log base 9 of 243. Let's see here, this thing's getting stuck on me. Okay, equals, first of all, I'm going to rewrite this log base 9, and I'm going to look at 243. And I'll tell you what, I'm not going to jump the gun on you guys. I'm simply going to work with this formula, okay? So I'm going to go log. Now leave this blank for now. I'm going to put 243 up here over log base 9, okay? Just like in the previous example, except now, remember how we talked about how a could be any base you'd like? if you were to really be familiar with these two numbers, I'm sure you are with this one, you'd consider a base 3, okay? Because, spoiler alert, this has a base 3 exponent 2 that works, and so does he, okay? I'm not quite sure. I can check on the calculator. It's 3 to some power, right? So, with that said, let's go ahead and rewrite it in those terms, right? So I got log base 3, okay, 243. Let's go calculate it. So let's see what you guys have been covering in class. Numbers, factor, 243, enter, and I see it's 3 to the 5th, okay? So then I'm going to come up in here, it's 3 raised to the 5th over log base 3 of 3 squared. Alright, so now that we've got in that form, some of you guys are like, oh, I see it. If you see it, that's a good sign. If not, hang tight. We've got the rest of the week. Once again, what the formula should come to mind is what? That inverse formula, right? So we got log base b of 3 to the 5th. Whoops, excuse me. I'm unable to multitask, right? Here's the formula, which reduces to x. We're going to apply it actually in both cases here, right? So here it cancels, you're left with a 5. Here it cancels, you're left with a 2. And we can even go further. Kind of divide that 5 by 2. Okay? Alright, guys. Let's go ahead and wrap it up here with this last one. This one says simplify log base 7 of x cubed minus log base 7 of x. Pay attention to this one. Now here, the first thing that I want to notice is that this exponent here, there's a formula for that, right? It wasn't the change of base, it wasn't the inverse, it wasn't the quotient or the product, it was what? The power property. So let's go ahead and remind us of what that looks like. This one says, how did we have it written earlier? Let's see here. Log base b of a p, right, can end up looking like what? P up front, log base b of a. Right? So we're going to go and immediately apply that up here in the front. So this one should now have a 3 up front, log base 7 of x minus log base 7 of x. Alright, what's the next thing we can do here? Okay, this one, although there's multiple ways to approach it, here's maybe the easiest one, is to observe that this is 3 times some quantity, and here, like always, right, that invisible one, it's 1 times some quantity. So because that quantity is the same, we can factor it out, right? It's log base 7 of x. So once you factor it out, you write what's left over, which is 3 minus 1. And the finishing touch is 2 log base 7 of x. Alright guys, thanks for all your time. Again, questions, comments, and concerns tomorrow. If you get it, great. If you don't, that's perfectly okay, because we got the whole week to kind of work on this. Okay, see you guys tomorrow.